Hello everyone, this is Mr. Ege, and today I'm going to demonstrate you how to use Inventor to create a rocket car model, solid model. And the reason we are going to generate this car is hopefully we're going to create an aerodynamic solid model version of the rocket car, and we're going to 3D print it, and we're going to race it and on the runway, and we're going to measure the time that it takes for the 10 meters, and then we have some analysis to do right after that, okay? And in order to do all of this, you can use either AutoCAD or Inventor, and I'm starting right now Inventor, and it's in front of me, and it is supposed to be a new drawing, okay, a new project. So I'm going to go to the Inventor part drawing, and I am selecting right now part drawing, click on it on the upper left-hand corner, and it's now generating, Inventor is generating the screen for me. And dimensions are the most important part, and those dimensions are given also in the Schoology, in the same driver, okay? And I'm going to also demonstrate it here too. So please stick to the dimensions. First, we're going to create a solid model of a solid model of the car, and then we're going to refine the design, okay, to increase the velocity, to make it more aerodynamic and also lightweight, okay? So, but this is going to take a second step, two-step process, all right? So now we have Inventor started in front of us. We need to choose a plane first. So to choose a plane, go to the origin on the left, on the project browser, on the left-hand side. Click on the plus button next to the origin icon. And I am choosing the YZ plane, one on the top. Click on it. As soon as I click on it, it gets highlighted. Then in the middle of the screen, I have the icon called Create a Sketch. So I move my cursor over the icon and I click on it. Now the sketch is created. I have two crosshairs intersecting each other with the yellow point in the middle, which is 0, 0 reference point that I'm going to start my line from. This rocket car is going to be 12 inches long, and first thing I plan to do is to create a 12 inches long line, okay? So I go to line command on the top left second icon and click on it. That enables me to start line command. Move my cursor carefully to on the intersection point of the two crosshairs. When I move my cursor on the center, computer shows me a green dot. Click the left mouse. This is the indication where I click the right mouse button, okay? As you can see, I'm extending my line, but this is going to be car, which is with the 12 inches long car. So I am literally extending line as perfect as possible, horizontal as possible. And now the dimension is, length of the line is highlighted in blue. I'm typing 12, enter, okay? So that will enable you to get to see the end of the line. As I roll the thumb wheel forwards, okay, the image gets smaller, 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 so that I can see what's going on. Now I'm moving my cursor at the end of which there is a line connected, okay, up, perfectly perpendicular, taking my time to make it perfectly perpendicular, standing still. I remove my hand from my mouse, and the height, okay, is supposed to be 2.625. Okay, so I'm typing 2.625. This is, where is it coming from? And this is coming from the size of the balsa wood, okay, that originally this competition is designed from. So enter key, okay? And enter again, I'm out of the line command. Now again, go to the line command, and this time start from your 0, 0 point. When you see the green again, click, move up. That height, again, move up perfectly, and computer is asking you to enter. This height of the vertical line is supposed to be 3/4 of an inch or 0.75, okay, or 3/4. So if you type 0.75, that's good enough, enter. Okay, now we have a vertical line, 3/4 of an inch vertical line. Move your cursor all the way to the last line that you finished, okay? And when you find the end of the line, computer will show you in the green dot, click on it, okay? That way you have a closed polyline right now. So hit escape key because you're done with the drawing lines, all right? And this is the point you want to sketch, finish the sketch and extrude. And how much is the extrusion going to be? This is extrusion is 1 5/8 of an inch or 1.625, okay? So I'm finishing the sketch. On the top right corner, there's a check mark called finish the sketch. Click on it, okay? And I'm selecting the extrude command, okay? And extrusion, I'm choosing two-way extrusion, and I am changing the size from the default 1 inch size to 1.625, 1 5/8 of an inch. So 1.625, I'm typing 1.625 extrusion, okay? And enter. So as you can see, I'm not clear my screen. So I need to change the direction of my viewpoint. I'm selecting the orbit command on the second command from the bottom on the right hand side, and so that I can see what I just created. And you can see now what I just created. Okay, this is roughly the size of the material I have, but this is going to change a lot. We're going to make it look like an actual rocket car. But this is the right time to save it, okay, in OneDrive. Just make sure that you save it in your OneDrive. Don't save any place you can find. Please don't do that. You're going to lose your drawing design, okay? So please go to the click on, go to the file and click on Save As and find the OneDrive, okay? Okay, and go to the file folder that carries your name. Okay, if you created already folder for this project, this is good, or for this course, which is STEM design, this is good. If not, just create. So this is a rocket car. So press the cap locks and just type the name of the drawing, rocket car, okay? And change the name of the drawing from part 1 to rocket car. Don't save it as a part 1. There is a name for every single design, so we have the rocket car. Change name to rocket car, okay? Yeah, IP.ipt. .ipt stands for inventor part drawing, okay? And save. Cool. This is done. Oh, one more thing, very important. There's supposed to be a hole at the back. The hole in the back is critical, okay? And I'm going to change the direction so that you can see I'm using orbit command again, okay? And the hole in the back, okay, is supposed to be created on the surface here. Okay, that hole, what does it serve? That hole is actually from CO2 cartridge, okay? It's critical, and that's so that we can create a hole approximately with diameter of 3/4 of an inch, and it's cylindrical hole, and the length of it is about 2.25 inch. Okay, this is cylindrical. So how do we do that? Press the right mouse button and okay to get out. Select this plane first. This is what we do continuously. You learn from the day one. Anytime you deal with the inventor, okay, part drawings, what do? You select the plane, then you create a sketch, then you draw, then end of the sketch, and then exit, okay? Extrude or what create 3 dimensions. So I'm selecting the face, the plane first, click. As soon as I click on it, the computer knows what I want to do, so it gives a bunch of options. The last option is actually my first choice, which is create a sketch. So click on this create a sketch, ta-da, and I have this in front of me. So now I'm ready to draw a circle, first of all. The exact location of the circle is very important. So I want the circle to be perfectly centered, but not vertically, but horizontally perfectly centered. So to do that, to serve that purpose, okay, I'm looking at my dimensions, okay, 1.625, and I'm going to create a circle, okay, and in equal sides. So this is 1 and 5/8 of an inch. So if you divide 1 and 5/8 of an inch by 2, what do you get? 1 and 5/8 of an inch. What do you get? Only 1 and 5/8 of an inch. If you divide 1 inch by a half inch, okay, that is 8/16 of an inch, and 8 plus 5 is 13/16 of an inch. So this is we're going to draw a 13/16 of an inch, okay, line from the top left, okay, to designate the center point. So when you start the top left corner, you type 13/16, enter, okay, and now you can draw the line, a line, okay, and what is the length of the line supposed to be? Again, let's make it 13/16 of an inch also, okay, and so we have 13/16. I'm typing literally 13/16, enter, okay, and enter, and I'm done drawing lines. And why did I draw this line? First of all, okay, this is the way we're going to center, okay, and let me at this point, let me double check my dimensions, whether they are perfect or imperfect, just to see. I have the model here in front of me. Okay, so it's 1.5 inches, not 13/16. It's a 1.5 inch centered. So I'm going to erase this last line. Look, it's never too late, right? And if you know, okay, what is correct, you start 1.5 inch. This line is supposed to be 1 and 1.5. So enter. Okay, enter. So this is the approximately half of the distance from the top end. Okay. Now, the reason I drew this last line, because I want to establish the center point of the circle. Okay, so I'm creating a circle now from the end of the line, starting from the end of the line. Okay, now computer is asking me what's the diameter. Diameter is 3/4 of an inch, or 0.75. So I'm typing 0.75, enter. Okay. Okay. So I guess this is accomplished now. And now I'm going to finish the sketch, and I'm going to extrude the circle. And how much is the extrusion? 2.25 or 2.25. Okay. So I'm going to go finish the sketch, go to extrude command. I'm going to not add extrusion. I'm going to cut extrusion. Okay. And it's not going to be 1 inch as default says. It's going to be 2.25 extrusion. Enter. And okay. Save. Again, save your work. Okay, this extrusion is finished too. And the nice thing about this design is that you have the beginning model in your hand, the rough model in your hand, but there is no design yet. So how are we going to design it? We want aerodynamic, we want a lightweight design, and the structure, the aerodynamic structure, lightweight design. We need to do some cutting, and we're going to later on add some wheels as well. But this is at least what you should have in your hands to begin with before your design starts. Okay. This is exactly the same model that you used to use. Okay, with the wooden version of it, of this activity. It's a competition. It's a national competition at several levels, okay? And I'm right now I'm suggesting get a side view of this design, okay? This is your side view, this is your front view, this is your side view, all right? And now start designing something in your mind. So what I did is, before I started recording this session, I designed a couple of examples on a blank sheet of paper. I suggest you do that too. And then I finally, okay, decided on what I'm going to do. So I have a very clear idea of, okay, how the design is supposed to be, okay? So I'm going to attempt to what I sketched on the blank sheet of papers right next to me, and probably you will do the same. What do we want to do? We want to reduce the mass. Too much mass definitely reduces the velocity, number one. Second, we want to make the corners round, okay? And we want to make it aerodynamic to reduce the friction. And sharp corners are pretty bad, okay, for the race cars or rockets or anything that wants to accomplish high velocity. And we want to make it aerodynamic. We want to have the minimum size, weight, okay, volume has to be reduced as well. All right, so why don't we do this? And I select the surface as usual, click, and create a sketch. Okay, click. And sometimes I'm going to need some arcs, sometimes I need some lines, straight lines. So I'm going to start a straight line, somewhat like this, okay, like that, something like this. And enter. I need an arc at this point, okay? And if I create an arc, something like this, that's going to be pretty much what I want to accomplish. Let's see. That's one part that I'm going to subtract from the design, okay? And another thing I want to create another line command, perhaps, and that goes all the way from here, approximately here, okay? And maybe I want to go like that, enter, and line command again. From here, I can come here and okay. Line has to be from the end of the line, okay? Now, probably you're thinking, what is Mr. Ege doing now? But when I'm finished, you will see what I was trying to do, okay? I need an arc command, okay? Something like this, perhaps, okay? And then probably I need another arc. So from here to all the way to perhaps here, okay? And perhaps one more arc starting from here. Okay, like that. And from there, I can literally generate a line between two ends of the arc and the line here, okay? That's going to be, that area is also going to be extruded and subtracted, all right? What else? I want to reduce, so I need another arc, perhaps, and I want to reduce the friction by reducing the mass, okay? So I want to go like, kind of like this, okay, and go like that. And perhaps I should choose another arc from this corner, kind of like that. Maybe I should draw a line in between. That will definitely help to close the loop. Okay. And another line command from here, perhaps down here, and go like this, perhaps here, and go back to here. Okay, so looks like I'm almost done. What else would I need? Reducing. It really helps if I can reduce that mass more. Perhaps something like that. And go like this, and then go like this. Okay. All right, I guess that's about it. And oops, this end of the lines are very crucial to meet, and if they are not meeting, make sure that they literally touch. Oops. Okay, maybe we should erase that line and then redo it. Okay, line. In this program, each line is a program as well. Okay, so how many parts do I have to subtract? 1, 2, 3, 4 parts will be subtracted if I extrude them. How much is the extrusion going to be? Same extrusion as we did before, 1.625 or 1 5/8 of an inch. So I'm going to go to finish the sketch command, okay, and select the extrude command, select the subtract command, okay, and the areas need to be subtracted. Like that. Okay. Let's okay it and see what happens. Okay, so we have a shape like this, a design like that. And I did my best to reduce the mass when the mass is reduced, okay? Maybe it is too much. I did a little bit overdid it, and I'm going to Control Z this, bring it back. Okay, this was overkill. So I'm going to go back to the sketch again and make some modifications on this one. I'm going to bring this line down here. Okay. And because this time I'm cutting the whole two, I don't want to do that. So I'm going to do this, finish the sketch. Okay. And extrude command again one more time. And I'm going to select cut option and select okay, and areas that I like to cut. I think it looks good now. And now okay it. All right, and save my work again. Okay, cool. Is this enough? Not yet. We're getting there. So we need to remember I said that in order to make it more aerodynamic, you need to make corners, sharp corners round. So we need to use the fillet command, okay? Fillet is a nice command, but you have to be careful with that when you're working with the fillet. You could overdo it or underdo it. For example, when you click on it, 0.125. 0.125 is 1/8 of an inch fillet, and it's not much. So you want to reduce, maybe increase it like maybe 0.25, perhaps, okay? And then go with that, if you can, to see if you could make it more aerodynamic as much as possible, okay? And now it's getting more aerodynamic. Now dynamism requires the top surfaces to be round and bottom surfaces is okay to be not round, okay? That's a very critical piece of knowledge about aerodynamic shapes. Oh, and at one point it refused it. So, but this is my interpretation. Maybe it didn't refuse, but it did stop showing me what's going on. Okay. Okay, there it is. Okay. And this looks good, literally very good now, or at least, and okay it and see what it's going to look like. Okay. And I'm going to save it. Always save your work, and there are several reasons when I say that save your work. Literally, it's good for your computer, and operations. Okay. I want to try this fillet command one more time with the one sharp area and see if we can do this. And it worked for me, and okay, it's really cool. Okay. And let's see what else we can do. In the front, it really helps if I can make it aerodynamic on the side. So go to fillet again and choose this line. Oh, no, good. So make it like less aerodynamic here. Instead of 0.25, maybe we should type 0.1 and 0.1 here. Even that is, I didn't like it, so cancel. Okay, that's better. We can go to fillet with much less filleting, 0.1, and only to touch the top. Okay, and okay. All right, so we have this funny, interesting shape, okay, in our hands, but this is all aerodynamic. It's all. I want this. The rocket car reach to the maximum speed, okay, by just reducing the weight and velocity, increasing the velocity to maximum and continue, okay? Next thing to do, and it's going to break probably in the first time it, okay, encounters a block, another obstacle, impacts another obstacle, it's going to break down because it's so fragile right now. However, I need two more cylinders, two more holes on the body so that I can insert the axles, wheel axle. There's going to be wheels, okay? So the wheels, I believe, is 1/8 of an inch. Let's go with the 3/16 option, diameter option, okay? Let's make it a little bit larger than necessary. So I'm selecting the surface, creating a sketch again, and the wheel is going to be somewhere around here, okay? And the first wheel in the front, okay, click here, okay? And we can type literally 3/16 of an inch, 3//16, enter, okay? And we need one more right here, again. And I'm lining up the centers, okay? And now I'm typing 3/16 of an inch, enter. Okay, this is good. And the total, now I'm finishing the sketch to extrude the wheel axle holes and hubs, whatever you like to call it. Use the extrude command. You select the cut extrusion, okay? And the total extrusion is going to be 1.65 or 1 5/8 of an inch, okay? So I can type here. Oh, it's already 2.25. Okay. I think it's bigger than 1 5/8 of an inch, obviously. So I'm gonna select. Oh, we did not select it yet. Select the profiles. Only two profiles to select. This. Let's change the number. Okay, 1.625, 1.625. Okay. And extrusion. and in one direction, and you select the area. And for some reason, my laptop is not acknowledging the circles. I'm going to cancel this and try again. Sometimes things do not work in the first time. So it's a good idea, okay, to do it again when necessary. So extrude command and select. Okay, good. And then select. I'm moving my, if you notice, I'm moving my cursor around the circle until it is selected, okay? And now okay. So computer lets you know whether it sees the circle or not by changing its color. So you have to be, okay. And I think it's perfectly done. Cool. That's the design, and that's also it is the end of our today's session, okay? I want you to design this one and export it to .stl file and let the teacher know, show the teacher know. In order to print this, that STL file has to be converted into MakerBot or Ultimaker. Print files, okay, the teacher's laptop has it for now, currently, and then we're going to print it from there, okay? All right, thank you very much for your time. Have a great day.